Actually, this is assignment number 6 of alcohol, phenols, and ethers. IUPAC nomenclature. First compound, IUPAC name is methoxyethene. Second, CH3C, Cl, CH3, OCH3. This is the longest chain you can count in any direction. This is 2-chloro-2-methoxypropane. 2-chloro-2-methoxypropane. And last structure is very simple. It is phenoxybenzene. Phenoxybenzene. Now, fill in the blanks. First sequence. Tertiary pentyl chloride with aqueous NaOH will give an alkene according to Say's rule. This alkene on hydration will give alcohol, and this alcohol will be according to Markovnikov's rule. Then oxidation of this tertiary alcohol will give two products. You can check in your notes also. One product will be acetone and the other will be acetic acid. This very example you'll find in notes also. Second sequence. At the end, we are given normal propyl ethanoate. I'm writing the structure here. To prepare this alcohol, we need propanol, and the second part comes from the second reactant. And according to the reaction conditions, we are given acetyl chloride. From acetyl chloride, this part will come. It means F is 1-propanol. 1-propanol is obtained by hydroboration oxidation in 2 steps. It means E is tripropyl borane, B is propene. And this propene is obtained by the reaction between B and C. B is obtained by the reduction of A. See, B is an alcohol because alcohol on dehydration will give alkene. It means C is sulfuric acid at 170 degrees centigrade. There are two options for A and B. It may be 1-propanol or maybe 2-propanol. 1-propanol can be obtained by the reduction of aldehyde. This can also be a carboxylic acid, remember that. And 2-propanol can be obtained by the reduction of acetone. It means if A is this, B will be this. If A is this, B will be this. After that, answer will be same. Third sequence. A is the Grignard reagent, reacts with B to give C. C, oxidation of C gives acetone, carbon dioxide, water. Even this you'll find as an example in your notes. Oxidation of tertiary butyl alcohol will lead to the formation of acetone, carbon dioxide, water. It means third sequence, C is tertiary butyl alcohol, and this is obtained by the reaction between A and B. A is Grignard, CH3, MgX. B is acetone. Fourth sequence, A plus B gives anisole. This is Williamson synthesis, and in Williamson synthesis we'll always use sodium salt of phenol and alkyl halide. It means sodium phenoxide and halomethane. Its reaction with HI excess. See, excess is just to confuse you. Otherwise, remember, bond between oxygen and aromatic ring is partial double bond. It is strong and that bond will not break. So products will be phenol and iodomethane. Phenol and iodomethane. So don't think that the second product is iodobenzene. No, it is just to confuse you. Explain why. All answers you'll find in notes. What happens when? I can explain verbally. Ethanol is treated with sodium metal. Of course, you have to write the balance equation and say then when it reacts, gives sodium ethoxide and hydrogen is evolved in the form of effervescence, bubbles. Second, anisole is treated with nitrating mixture. Its nitration leads to formation of a mixture of ortho and para nitroanisoles. Distinguish between, again verbally, of course you have to write exam balance equation in the exam. Phenol and cyclohexanol. You can use bromine water test. Phenol will decolorize bromine water, cyclohexanol will not. There's another test we can use, ferric chloride test. Phenol will give violet coloration while cyclohexanol will not. Second, 2-butanol and butanone. Remember, 2-butanol and butanone is 2-butanone. Both will give iodoform test, therefore iodoform test cannot be used. Therefore, we have to use, either we can use esterification, sweet smelling ester will be formed by 2-butanol, not by ketone, or we can use sodium metal test. Hydrogen in the form of effervescence will be released in case of 2-butanol, not in case of ketone. Now coming to conversions. Phenol into benzoic acid. I taught you two methods to convert phenol into salicylic acid. One was Rimmer-Timmer reaction using carbon tetrachloride, or we can use Cope synthesis. So you can use any one of those two methods, convert phenol into salicylic acid. After that, zinc dust heat. If you heat with zinc dust, phenolic group will be removed. This is called reduction, and we'll get benzoic acid. Second, benzene into para-nitrophenol. Convert benzene into chlorobenzene, halogenation in the presence of catalyst, cold and dark. Write proper reaction conditions here. Chlorobenzene into phenol. I taught you one method, that was Dawes process, aqueous NaOH, 623 Kelvin, 300 atm pressure and whatnot. Everything has to be written here. After that, we have to get one nitro group react with dilute HNO3 at low temperature, right? 0 to 10 degrees centigrade, dilute HNO3, you'll get a mixture of products, and this will be the major product. Benzene into salicylaldehyde. Convert benzene into chlorobenzene, chlorobenzene into phenol. After phenol, perform Rimmer-Timmer reaction using chloroform, CHCl3. The remaining conditions will remain the same. You'll get salicylaldehyde. Benzene into 1,3,5 tribromobenzene. Again, benzene into chlorobenzene, chlorobenzene into phenol. Now brominate it with bromine water. After that, heat with zinc dust, OH group will be removed. Aniline into picric acid. Aniline into diazonium salt. I told you the method. HNO2 HCl 0 to 5 degrees centigrade. Treat this diazonium salt with warm water. This will be converted into phenol. We'll find this reaction in preparation of phenols. After that, nitrating mixture, this will lead to the formation of picric acid, that is trinitrophenol. Next question. Out of benzene and phenol, which is more easily nitrated and why? Answer is phenol. And the reason is due to resonance, there is high electron density on benzene ring at ortho and para positions, so that the attack of electrophile becomes easy. Electrophile in this case is nitronium ion, NO2 plus. Arrange so-and-so compounds in the increasing order of their acidic strength. Now, this in fact is based on electronegativity. In one compound, there are 3 fluorine atoms. In one compound, there are 3 chlorine atoms. In third compound, it is just ethanol. It is ethyl group, which is electron releasing. So minimum acidic will be ethanol. After that, trichloro, because 3 chlorine atoms will have minus I effect, so that release of H plus ion will be easier. And maximum will be trifluoro, maximum minus I effect, so that OH bond becomes weakest. Release of H plus will be very, very easy. So same order as given in the question. But that was the last question to be discussed.